Hello students! The goal of this video is to learn how to rationalize. Rationalizing is a way of writing an expression in standard form, and in standard form you can never divide by a radical. And let me tell you why. These two problems look very similar, although one's much easier to compute by hand than the other. So I'm going to rewrite these. This says you're taking the square root of 2 and dividing it into 5 pieces. 5 divided by the square root of 2, which I'm going to write as a decimal. It's about 1.4142. On and on and on. And this says you're taking 5 and dividing it into square root of 2 pieces. So you're taking 5 and you're dividing it into this kind of piece. Now, which problem is easier to answer? Well, on the left side, I could put 5 into 14, figure out how many times it goes in there, blah, 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 do the long division process, and I could get an answer. But in here, I have to ask myself, how many times does 1.4142 go into 5? And I really can't answer that question without using a calculator. So back in the day, before people had calculators, they decided they needed to find a way to write these expressions without radicals in the denominator. And from then, it just became standard form that you can never have a radical in the denominator. Even though we have calculators, this problem we can compute by hand, whereas this problem we cannot. So the process they came up with is called rationalizing. And in order to rationalize, you just have to find a way to get rid of the denominator in an expression. Now, in order to change the expression, we want to write it equivalently, which means you can't change the meaning. So the only way to change these problems in an equivalent way is to multiply by what I call a fancy 1. Because if you multiply this problem by 1, well, it's still going to be the same problem. But 1's not actually going to change the form. A fancy 1 might be able to. So when I say fancy 1, I mean something like 3 divided by 3. It still means 1, but it's altering the problem. So what can we multiply this problem by that would clear the denominator and get rid of the radical? By now we should know that to undo a square root, its inverse operation is squaring it. So a square into the square root. Now, what squaring square root of 3 means is I'm going to multiply square root of 3 by square root of 3. So I'm going to use that idea and multiply this by our fancy 1. So if I multiply the denominator by square root of 3, square root of 3 times square root of 3 will just be 3. But whatever you do to the numerator, you have to do the denominator. The square root of 3 divided by square root of 3 is just a 1. So at the end, I'd have 5 root 3 over 3. Now, if you plug both of these into your calculator, you would get the same answer. So they are equivalent, with just 1 is standard form and 1 is a form that we can't necessarily compute by hand. Number 2 is a little bit different because you want to undo a cube root. So a square undoes a square root, but if I just do what I did before and multiply this by the cube root of AB on top and bottom, well, that's not going to undo a cube root, because in order to undo it, we have to raise it to the third power, or cube it. Cube root undo each other. So instead of multiplying just one time, we're going to have to multiply it by one more cube root of AB to the top and the bottom. Now that I've multiplied it twice, in total I'll be multiplying this 3 times, so I'll be cubing the cube root of AB, so I'll just be left with AB. And in the numerator, I have the cube root of AB multiplied 2 times, so I'm going to rewrite that as the cube root of AB squared. Which this is a good answer, but we could go further based on what we've learned about rational exponents. I could rewrite this as AB to the 2/3 power. So the index becomes the denominator, the exponent becomes the numerator. And the reason I do this is because then we can use exponent rules and simplify this. So it's really combining everything we've learned so far. So remember, when you divide, you subtract the exponents. So I can write this as AB to the 2/3 minus 1 power, which is just AB to the negative 1/3 power. And we can apply another rule that we've learned, which is when you have a negative exponent, to turn it into a positive exponent, we can bring it to the denominator. Now, I hope you're all saying, wait a minute, Miss Mancini, isn't that the same thing as the cube root of AB in the denominator? Okay, I kind of did that for a reason. One reason, I wanted to practice what we've already learned about exponents. The other reason is I wanted to show you that this is, in fact, equivalent to our original answer. Isn't that neat? So I don't want us to have any roots in the denominator, so I would leave my final answer like that first step there. Sorry for tricking you. But let's try another problem. And this one's a little bit different because you have a binomial in the denominator. So I want to try, okay, I have a square root, so if I just multiply by square root of 3, what would happen? And you'd have to distribute the square root of 3 to both terms. And while that would cancel out this times this, you would be multiplying 2 times the square root of 3, which would be 2 root 3, which wouldn't actually clear that denominator. So anytime you have a binomial, you have to multiply by something called the conjugate. And the conjugate is just the binomial, but with the opposite sign. So if this is 2 plus root 3, the conjugate would be 2 minus root 3. The reason that works is kind of like the difference of squares problem. So in difference of squares, you had a minus b times a plus b, and the outers and inners canceled. Well, the same thing will happen here, and let me just write it out so we can actually see what's going on. If we multiply this by 2 minus root 3, and again, whatever you do to the bottom, you have to do to the top, which would be 2 minus root 3. And we FOIL this out. Let's see what happens. 2 times 2 gives me 4. 2 times negative root 3 gives me negative 2 root 3. 2 times root 3 gives me positive 2 root 3. And, okay, so we already know that when I multiply root 3 by itself, it just gives me 3. But it's going to be negative 3. So the good thing about this is if you do the same terms with the opposite sign in the middle, although you have to multiply 2 times root 3, the 2 are going to cancel because they have opposite signs. And then the root 3 times root 3 also gets rid of the radical because you're squaring the square root. So now that I've done that to the denominator, you also have to do it to the numerator, but I just want to show you why that works. So 5 times 2 and 5 times negative root 3 will give you 10 minus 5 root 3. Simplify that up. Like I said, these will cancel, so you have cleared the denominator like you wanted to. 4 minus 3 gives you 1, and in the numerator you have 10 minus 5 root 3. Now we don't really need the 1. This is an equivalent answer, so we can just make it as simple as possible. And that is how you rationalize. I hope you enjoyed the video, and please come with questions.